Hello there, today we'll be doing min stacks. Let's check out this problem. So in this particular problem, we are given a class to create, and in this class we need to accomplish all of these tasks in over one time, and the task is to create a stack at which we can return the minimum item in the stack at that particular time, and be able to pop items on the top of the stack. So I think this requires a data structure because retaining a minimum item value. Suppose we have that value and we have a 5. That's a 5, right? Then we have a 3. Suppose the minimum value is now 3, and minimum value is, let's say, 1. And then we put a 2 in, and that's not the minimum value. Okay. So let's say we remove the 2. Oh, sorry. Let me put the 2 in here as well. So 5, 2. The minimum value was 5. Then it was 2. Then it remains 2. Becomes 1. Becomes 2 again. So let's say we remove the top one, right? And now this minimum value, we'll just grab the next one. 1. That's perfect. It's still 1. But when we remove the 1, it will look to the first one and say, oh, it's 3. Well, that's not correct. So what we need to do will be to look through the entire stack to get the right answer. Of course, looking through a whole stack is O of n and not O of 1, and that's way too long. So where can we store the minimum value? Another place to store the minimum value is in the value itself that we're storing. So we're going to store the 2 here, the 2 here, the 1 in here, and 2 and 1 here. When we remove the 2, we can remove the minimum value 1. When we remove the 1, oh, the minimum value we know at this point in time, at this particular point in the stack, is a 2. So anything above this, if it's greater than 2, it's still 2. Because we stored that piece of information when we pushed the information in. And with that, we are able to give the most top item, which is 3, and also give the most minimum item, which is 2. All right, let's get this problem started then. So in this particular problem, we need a self.stack equals empty array. And let's say what we're going to hold is the value and also minimum value at stack location. So let's start pushing the items in. If self.stack, if the stack exists, let's get the minimum value at stack location. This is going to be the min between the most recent minimum stack item, so stack at a -1 at 1, and the current value. And we're going to store that. So self.stack.append actually, a better way to do this is equal to val. And then if it exists, then we add that value just immediately as our minimum value at stack location. Otherwise, we'll check for the min. How's that? That looks pretty good to me. This way, we know exactly what we're doing. When we read the code, we are getting the minimum value, and if there's an item in the stack, then let's check that if that our current value is at the minimum value at this location in the stack. Okay, so if stack, let's pop. So stack dot pop. Of course, what we need to do is self.stack, because which stack are you talking about usually, right? So if self.stack, we get the top item, like top, we're getting top value, which is equal to stack, -1, and 0, 1, 0. 0 is the stack. So return top value. If self stack, then we're gonna get the minimum. So min value is equal to self stack -1, 1. And then we'll return min val. One thing we can do is use this function in here. But that's I think that deviates from what we want to do, because this does not do this job. Okay, it's a little slow this time around. I wonder why. I think it's because of this. Let's run it again. Okay, now it's very fast for some reason. I think it has to do with random data that we're inputting. So everything runs in O of 1 time, and by using this data structure, we are able to get the results that we wanted. And the way we used the stack was retaining at this particular point what is the minimum value at this location. This is by caching the minimum item at each particular point in the stack. So, can we write this code better? I mean, of course we could. Do you think this looks good, or is this better? Like, this better? Or is this better? I think this looks better. I just think that looks better. I don't know. If you ask me, this looks better to me. Because this tells us exactly what's happening. Oh, if there's an item in the stack, let's check. If there's no item, let's just add the value. That makes more sense to me. This code makes a lot of sense to me. Why would I say that this is a top value and this is the min value? It's because this way we can like read at a glance what this variable's about in the future when we do read it, and not just see stack -1, 0. What the heck does that mean? Like, where is that coming from, right? Like, I don't know what that's about. So then I will have to go back to stack and read this and be like, oh, we're looking at the minimum value at top stack location and value, and we're returning the value. And at this point, we're returning the minimum value at the stack location. Okay. Or I could just read this line of code. Oh, I'm getting the top value. Great. Or minimum value at stack location. Great. So that's why we have this code here, to make sure that it's more readable for the next user and for myself in the future. And with this line of code here, why we split it up is because this way we know, oh, what we're doing if there's a stack and what we're doing without a stack. I mean, otherwise it's kind of a little bit more confusing, I would say, less readable. And with that, I think we have completed this particular problem. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. And if you have any questions, please comment and let me know what your questions are. Thank you very much. I'll see you